Good day, students. My name is Dr. M.A. Salau, Department of Physics, University of Unilorin. I'm here to demonstrate the practical titled Measurement of Internal Resistance of Cell by Potentiometer. The aim of this experiment is to measure the internal resistance of a dry cell using potentiometer. The apparatus required, we have the potentiometer, as you can see it. Then we have the power supply. In this case, our power supply is serving as our accumulator. Then we have the dry cell. This is the dry cell that I want to measure the internal resistance of it. Then we have the milliammeter. The correct ammeter to be used is milliammeter. If you use ammeter, you may not see the variation in the small current flowing in the circuit. Then we have the galvanometer. Then connected to the galvanometer is the junkie. Then we have the switch. This is the switch. Then we have the resistance box. So what we are expected to do is to measure the balance point or null point when the switch is open and when the switch is closed. The balance point when the switch is open is our L naught, which is equivalent to the EMF of the cell. And when the switch is closed, we are going to vary several values of resistance. That is, from R is equal to 10 in steps of 2. R equal to 10, 8, 6, 4, and 2. Then we have to obtain the balance point for each of the readings. So before we go to the real theory of this experiment, as you can see on the board, we have listed the apparatus required and we have seen the diagram. The connection is what we have explained. This is our accumulator. The positive pole of the accumulator is connected to the one end of the potentiometer, which is A. Then you connect the test cell, which is the dry cell. You connect the positive of the dry cell to the end A. Then you connect the negative of the dry cell to the ammeter. Then this is the protective resistance, which is optional. You will not use it. Then you can connect that to the galvanometer. Then you now connect the resistance box with the switch across the dry cell. So this is the connection. So now, as I've said, that what we have to do is to measure the balance point when the switch is open, which is our L naught, and also measure the balance point when the switch is closed. For R is equal to 10, 8, 6, 4, and 2. The EMF of the cell is proportional to the balance point when the cell is not delivering any current. And when the cell is delivering current, V is proportional to L, according to Ohm's law. So if equation 1, divide equation 1 by equation 2, we are going to have E over V equals to L naught over L. That can be equation 3. And when you make V the subject of the formula, we are going to have EL over L naught. That can be equation 4. From Ohm's law, I equals to V over R. When we substitute that, we are going to have I equals to EL R L naught. This equation 5 is very important. That is the equation you are going to use to measure the true current in the experiment. So E is equal to I bracket capital R plus small r. The aim of the experiment is to measure this internal resistance of the cell. And this R is our resistance that of varying value from the resistance box. So from V equals to IR, that is equation 7. If you divide equation 6 by equation 7, you are going to have E over V equals to R plus R over R. The I has cancelled out. Then, when we make substitution from equation 3, E, the ratio of E to V, which is L naught over L, you have L naught over L equals to R plus R over R. So, we are going to write this equation 9 in a way that we should be able to plot the reciprocal of the balance point and the reciprocal of the resistance used. So, when you do that, we are going to have 1 over L equals to 1 over L naught, 1 plus R over capital R. So when you compare this equation, I further book it now so that we can have the slope and the intercept. When you compare this with the equation of the straight line with intercept, y equals to mx plus c. So when you plot the graph of 1 over L in per meter against 1 over R and per ohm, you are going to have a straight line graph with intercept, and the slope of that graph is what we are going to equate to the coefficient of the RA 1 over R, because you plotted 1 over R on the x-axis. So the coefficient of 1 over RA is R over L naught. That means the slope obtained from this graph is going to be equals to R over L naught. Don't forget, L naught is constant. That is the balance point when the switch is open. So then, from there, you can get your internal resistance R. So when you do the experiment, as I've told you that the experiment, you have to measure the balance point when the switch is open. The milliammeter, to obtain the current on the milliammeter, let's try to balance one. When you want to use a potentiometer, you first of all test the 2 points, the extreme length, the left hand side and the right hand side, and you ensure that the galvanometer deflects both sides. So let me test for the right hand side. You can see the deflection. Then the left hand side, you can see the deflection. So I can know that my circuit is properly connected. Now the next stage is to, you can see that the switch is open. Look at the switch. I'm determining L naught. So the switch is open. I'm not using any value of R. So I will now obtain the balance point. To obtain the balance point, you have to make sure your jockey is in connection with the wire of the potentiometer to obtain the balance point. Can you see it? So this is L naught. Then you simultaneously read the reading on the milliammeter. The value on the milliammeter here is around 0.02, even though it's that is when I touch it that you take the reading. Can you see? That's around 0.04. So you take note of the ammeter reading. So you can have that one in your table. After we have finished all this procedure, I can clean this side and have the table. Now, the measurement you have to take, you have to take several readings of R. That is when R is equal to 10, you measure the balance point. When R is equal to 8, 6, 4, and 2. The reciprocal of that R, you find the reciprocal in this column. Then the balance point you obtain, we call it in meter, is in centimeter, but you convert it to meter. Then you take the reciprocal of the length, which is 1 over L in per meter. Then for each corresponding value of the balance point, you check the ammeter reading. Then you record the reading on the ammeter here. Then by calculation, in one of the maybe equation 5, I think, which is I is equal to EL over R naught. So you use that calculation to get the true current. Of course, I told you that L naught is equivalent to E. So when you use that calculation, you take several values on the true current. Then the difference between the ammeter reading and the true current, you record it in this column of correction. Then you plot the correction on the y-axis against the ammeter reading to see how the graph look like. It's like a zigzag something. You have some points at the upper side, you have some at the downside. Then the second plot, using the same table, is to plot 1 over L from this table in per meter against 1 over R to obtain this slope, and equate the slope to R over L naught, which is the coefficient of X, and you plot it. Then from there you can make R the subject of the formula, which is the aim of the experiment you have performed. That's several other questions. When you plot your graph, that is, you are plotting 1 over L in per meter against 1 over R in per ohm. You have the straight line graph, which when you compare coefficients with the last equation here, you calculate the slope and equate the slope to R over L naught and make R the subject of the formula. Don't forget, your L naught is constant. That's the balance point where the switch is open. So thank you very much. If you have other questions, and you have to